Okay, welcome. So we'll be starting chapter 8 today. In chapter 8, our goal is to discuss arrays, strings, sequential search, bubble sort, and there are different types of arrays. Initially, we'll start with parallel arrays. We'll discuss a single dimensional array or unidimensional array. Then we'll, at the end of the chapter, we'll discuss very briefly about two-dimensional array. All right, so our goal is to understand what are the arrays. If you remember, in the past, we have discussed this slide. This slide is available on our platform. This slide shows you what are different types of data types in C++ programming language. And if you remember, I talked about the character data type, integer data type, Boolean data type, double data type, and those are the data types we have been using. And I also had mentioned in the beginning of the class that later on we'll be discussing structured data type. So this is all simple data type. So far what we have been using in the first 7 chapters is simple data type. So today we'll learn how to use structured data type. So there are different types of structured data type. In fact, we have a chapter on arrays, which is chapter we'll be discussing today. Next week we'll be discussing data structures. The following week we'll be discussing the classes. And if we have a chance, we'll visit unions as well. We also have been talking about address data type. In fact, we have been using references. For example, for a previous project, some of you are using references. In fact, probably it is required to use references. If you join advanced programming, we'll be also learning about pointers. So in this particular book, chapter 12 is all about pointers. We do not discuss pointers in Introduction to Programming Language. Okay? You guys okay? So this is our goal, to discuss arrays. And hopefully, after we are done with this chapter, you'll have pretty good understanding what arrays are. Now, according to your book, the definition of arrays, so this is what your chapter begins with. It talks about simple data type versus structured data type. A structured data type in which each data item is a collection of other data items. So each data item is a collection of other items, which means maybe I can declare one variable, and that variable can access multiple pieces of data. In the past, in the first 7 chapters, when I declare a variable, I can only hold on to one piece of data. So we'll see if we can have a collection of data. So this is from your book, a collection of a fixed number of components, all of the same type. So if I declare an integer num, and this is the size of the integer or the size of this variable in square brackets. So I'm saying I would like to save 5 pieces of data, or allow me to allocate 5 spaces, holding areas for this particular data type. So if I want to declare a character, I can simply say char middle initial, that's my variable, with size 10. So in this case, I'm declaring an array of character type with 10 different values can be stored. If I would like to declare strings, I can say strings, first name, size 100. Now I can store 100 first names in this variable. If I want to declare doubles, I can declare doubles, salary, size 20. I can declare booleans, flag, size 25. So as you can see, just by the declaration part, I can create different variables of array type with different sizes. When I run this command here, or when I run this command here, the compiler goes to the memory and allocates or allows it to allocate that much space of that type. For example, for integer, we need 4 bytes. So if I'm creating 5 components, 4 times 5, 20 bytes are allocated for that variable. So that variable can use that space to store future values, or values which can be initialized right at that time. Assuming these are the values, 15, minus 18, 45, 0, 11 for this array here. Now, visually, if you want to see it, when this variable is declared of num type, so it goes to the memory and it has the access to 5 elements. These are called array elements. So there are 5 array elements. Your book also calls them components. I like to call them elements. You'll see these words interchangeably. So these are 5 elements, and I can access these elements. Now, how C++ does, and many other programming languages, the starting index or starting location of the first element is 0th index. So you start with 0th index, and the last element will be 1 less than the size. If the size is 5, 1 less than the size is 4, because you have 0, 1, 2, 3. So technically you have 5, but this is how it begins. The creators of the language, when they were planning for this language, that's how they started. In most of the programming languages, that's how it is. Can I start with 1? Yes, you can start with 1. Then you lose this. You will be wasting this extra space, which is available to you. So if you say, I just want to start with 1, yes, you can start with 1, but you still have something available to you in the memory. So if I want to access, or if I want to display the first element's contents, I can simply say cout, name of my variable, which is num. And if I want to display the first element, I will simply use the index. And this is called index or subscript. So what it does, it says, OK, show me the contents of this location. And this location is right there, 15. 15 will be displayed in that case. If I want to access the last element, what will be the index? 4. What if I say num5? What will happen? Num5. Yeah, so it's going to give you an error message because you're trying to access something which is here, which is not part of your boundary. So this is your house. This is your neighbor's house. You cannot access your neighbor's house, contents from the neighbor's house. So that's illegal. So we'll see what kind of error message we will be getting. And most of you will be getting that error message for project number 8. Now, that error message typically is array out of bound, that you're trying to go beyond the boundary of your array. Can I access the element over here? No, because that's not part of my array declaration. Whatever you have array declaration, those are the only components you can access. Now, I want you to mention a couple of things here. I really want you to understand that's where the data resides, but each element has its own address. So if this is the first element, it has its own address. And you can see the address by using the ampersand sign. If you remember, we have this special symbol, ampersand sign symbol. If I want to see the address, I can use the ampersand sign. And if I, let me say 0, if I just put the ampersand sign here, what will be displayed? 1000, assuming that's the starting address of this first element. Assuming, let's say that's the address. Now, this element has its own address. This element has its own address. So each element has its own address. But the arrays in C++, they make it really easy for us. They say, you know what? You don't have to remember all the addresses of each component. What if I give you the starting address and all other elements are contiguous? So if I can give you the starting point, maybe you can access the next element and the next element and the next element. Don't you agree? So if I say, if somebody comes to me, another faculty member says, I would like to know the contact information of all of your students. I tell that faculty member, why don't you come to me, the starting address. If you come to the starting address, you can access other student information as well. From me, you can find other students' information. So here, if I can get to the first element in the memory, I should be able to go to the next one and the next one and the next one. That makes it really easy. Which means that if I have the access to the this particular array variable, I should be okay. So coincidentally, the starting address is stored in the num itself. So if I display num, just by num by itself, what do you think what will be displayed? Yeah, the starting address, which is exactly the same information you can access from here. So in this case, you will access 1000. In this case, you will access 1000. So this looks a little bit more complicated. So instead of using this whole thing, I can simply use the name of the array variable that will give me the access to the where the array begins. This is very critical. This is called the base address. In arrays, base address is very critical, and that's how you communicate with other functions from main and from other functions, just by passing the base address. I'm going to make another statement here, and we'll be discussing that statement further. The arrays are passed by reference by default. I'm going to make that statement again. By default, arrays are passed by references, which means I don't have to use ampersand sign anymore when I'm passing an array element to another function or array to another function, because naturally arrays are bypassed by reference. Now, what exactly that means and how it adds value to us? Anybody would like to give a feedback? If something is passed by reference by default, how it's going to add value to my program? So if I'm in function 1, yeah, Daniel, and here's function 2, if I'm passing something from function 1 to function 2, how it's going to add value?
Well, you can mutate it more easily, and you don't have to copy it, so if it's a very long array.
Right. So what Daniel is saying that the other function gets the starting address of the original location, or the address of the original location. So if I'm actually in the main function, I'm looking at this starting address. If I go to another function, that function will be looking at the same location. So you don't have to make duplicate copies. If the second function makes any modifications, the first function can see those modifications. So instead of passing all these 5 or 10 different elements by references, it makes your coding much easier. Now you only need to pass one argument, not 5 arguments and not 10 arguments. It makes your programming much easier. So that's something we'll be discussing in more detail in a little bit. So this is called single dimensional array. This is your unidimensional array. So in unidimensional array, and by the way, if you learned something today, how many of you, this is the first time you're learning about arrays? So you will be using the same concept for many years to come. I learned this stuff, I don't want to reveal my age, but when I was a kid. Literally, I was a kid. And same concepts. In fact, I remember I was sitting in a college, and the professor, we had 100+ students in a class, and he said, he spent 10-15 minutes explaining arrays, and people were struggling, and he said, anybody in this class can explain arrays better than me? And I raised my hand. Went on the stage, and I spent 5-10 minutes. Everybody started applauding. Everybody said, now we understand. So he, after the lecture, remember I'm a student in the college. He was a department chair. He said, are you willing to, are you interested in joining us as a faculty member? He hired me. While I was a student, I became a faculty. And I was getting paid as well, not a volunteer job. So arrays, they have sentimental connection with me. So arrays is a simple concept. It makes your programming easier because now you make one declaration. Now you can have declaration of 5 elements or 500 or 5 million and on and on. So arrays make it easier to store large amount of data with one variable name. Previously, if you didn't have the arrays in the first 7 chapters, you had to say num1, num2, num3, num4, num5. You had to declare that many variables. Here, I don't have to do that. And same thing applies to other types of data, strings and doubles and other types of data. And then later on, in chapter 9 and 10, you learn you can also declare arrays of object type. Objects are complex things. And now you can actually declare objects, which we'll discuss next week as well. Let's move on to a couple of more terms. So we know what the index is. So this will be in your exam. You need to know what is an index. And this square bracket is called array subscripting operator. That's the name in your book. Array subscripting operator basically you need to use these two square brackets to indicate it's not a simple variable anymore. It's structured variable. It's a little bit more than a simple variable. So array always begins with 0th index. Okay? And this is true in Java as well and C#. So array always begins with the 0th index. And like I stated, I can change it. I can declare with size 6 and only access 1, 2, 3, 4, and 5. I can do that. But then I'll be wasting some space. There's no need to do that. And this is your array, what array looks like. If you declare an array of size 10, so the starting address is 0, the last starting index is 0, and the last index is 9. If I would like to populate the value in the 6th array element, this is the 6th array. How do I know it's a 6? Because it started with 0. So this is a 6th element. I can say equals to 34, and 34 will be populated here. If I would like to display the 6th element, I can say cout list 5, and it will display the 6th element. Okay. If I would like to use in a computation, I can say list 5 times something else, list 4. I can use in computation as well. And that's exactly what it's doing here. It's taking an element from array element 4, array element 7. It's adding them together. So then you'll get the results. So basic operations on one-dimensional array, you can initialize them. We should initialize them. So when you declare your array right here, I have not initialized it. I want to make sure all the garbage is clear. So later on, if I do the computation, I don't get erroneous results. You can input the data, just like what we noticed. We can take the data from the user, from a file, from a database, from any source. You can produce results. And you can also find the smallest and largest values. You can sort, you can search, you can do all sorts of fun things, which we'll be doing that today as well. Each operation requires ability to step through array elements. Because array is not a single value, so if you want to search or sort or populate, you have to step through, you have to cycle through. And what is the simplest way to cycle through? Loop. Yeah, like a for loop or while loop. Arrays, their sizes are fixed. So when I say size 5, it is fixed. So if the size is fixed, I can use for loop. For loop because for loop allows you to find out how many cycles you need to go through. You can still use a while loop, but for loop is an ideal loop in this case because you can easily cycle through 5 times, 0 through 4. So you'll see a lot of for loop usage when it comes to array. So that's what it's saying. You can easily accomplish this by looping through. So here's an example. So for I equals to 0, I less than 100, assuming the size of the array is 100, and then you can actually take all the data. Or if I remove this from C into some kind of if stream object, I can read from a file. Okay? You guys okay with that? Okay. So we'll get really comfortable with this stuff. We'll have pretty good understanding, and there's nothing difficult to understand. It's just that now we are taking one step further. We're going one step higher than what we have done so far. So in C++, there's no guard against indices that are out of bounds. That's what I was indicating here. If you want to say cout size, cout square bracket 5 or 6, C++ compiler is not going to tell you, stop, you cannot do that. It's going to just generate some kind of runtime error. So you need to take some precautions that you do not try to access something out of boundary. Yeah.
So in some programming languages like Java, if you try and access an array index that isn't part of the size, that's greater than or less than the size of the array. If you have an array with 100 elements, you can try and access the 200 element. What might happen is your program will crash with an exception. In C++, there is no guarantee that it'll check that your index is correct at runtime. So your program will probably run, but it'll do something really kooky because it'll actually access stuff that's 200 bytes away from the starting address of your array. So it won't tell you when you've made that mistake at runtime. which is really, really dangerous.
Yeah.
So not only will your compiler probably not catch it, but at runtime your program will run perfectly fine, but it might crash or do something weird. So it's one of those really spooky things.
Yeah, wonderful. Thank you for that input, Daniel. So that's what we will be, and that's why it's a good practice when you declare an array, also declare another variable called size, and let the other function knows what is the size. So if you say size is 5, the other function can only loop through 5 times. For example, in this case, I'm declaring right here, what is my array size? My array size is 5. That's the size of my array. Also, I'm declaring a simple variable size equals to 5. So when I pass this array, num, I'm passing it to this function here. I'm also passing the size. So this function can only cycle through 5 times, 0 through 5. So that's a good practice. So you don't want to do that. There are other ways as well, but this is a simple fix. So you do not go out of the boundary. You stay within the boundary of your array. We'll come back to this one in a few minutes. So arrays can be initialized during declaration. So there are different ways to initialize your arrays. And I'll be showing you so many different ways. But one of the simplest way to initialize your array is, especially if it's an integer, for example, you can simply say =0. All of the elements will be initialized to 0 just by one statement like that. So all the garbage will be clear. It doesn't matter if the size is 5 or 5,000. It will be initialized to 0. If it's double, you can initialize to size equals 0.0. So you can initialize that way. Or if you know the first value, but you do not know the other values, let's say the first value is t, and what it does, it initializes the first element with t, the other elements will be automatically cleared. For example, if I know the first element value is 15, I can put 15 here. I can put 15 here. So the first element will be initialized to 15. Others will be initialized to 0. So there are different ways, and the chapter talks about it. For example, if you know all the values, you can plug in the values right at the creation of the array, declaration of the array. But most of the time, we do not know the first values. You will not be putting the hard data inside your code. Remember, just to revisit to this concept here, data and program, they are not the same. Why do you write programs? Why you're developing software? To do what? To process the data. So data is something outside of your program. So this thing is a bad practice. Your data does not belong inside the program because now your program is not open to other types of data. So your program should be just to process the data. Data comes in from outside source, such as a user, some database, some files, something which is not part of your program. Your program should be generic. Program should be more high level, and it's more like a blueprint. So that's the purpose of writing code. In fact, that's the only reason we write code, is to process data. So here, it's just telling you if you know some values, and even if you have not provided the size here, notice there's no size here. At the time of the declaration of your array, size must be provided. But here, size is not provided because what the compiler says, let me count. 1, 2, 3, 4, 5. I'm going to give you 5 spaces to store double data type. So it calculates that way as well. And so values are placed between curly braces, size determined by the number of initial values. And that's another thing I indicated earlier. So int list 10. So all of them are declared to 0. Or in this case, notice the size is 10, but I only knew the first 3 values. So the first 3 values will be initialized to 8, 5, and 12. The rest will be initialized to 0. Okay? And here declares an array. Oh, just explains that one. some of the things are not possible. Some of the things are possible in arrays. So it says aggregate operation. Any operation that manipulates the entire array as a single unit, it's not allowed in C++. Example is if you want to copy the content of one array to another array. Let's say you have created my list right here, my list. Let's say this is my list. These are the elements. And you have declared another array with your list, also size 5. They're exactly the same size. I cannot say take the contents of my list and assign to your list that way. Why? Why this? By looking at it, this doesn't look right. What exactly my list, if I say see out my list, what will be displayed? The address. So here, I'm not dealing with the content, I'm dealing with the address. So here, technically what I'm saying is my address or my list address assigned to your list address. So that's not going to allow you to copy all the contents. If you want to copy all the contents, such as 0, 4, 8, 12, and 16, all these 5 contents to your list, you have to go through each at an individual level. And that's what I'm saying. Take the 0th value, assign to the 0th value of your list. Take the first value, assign to the first, second, third, fourth. So you have to go cycle through that. So that's what it's saying. Aggregation operation in C++ is not permitted. So this is the key in arrays. This actually makes the purpose of why we use arrays. This is one of the reasons. But arrays are by default password references. This is a very important concept. In fact, this is the highlight of this chapter, that if I declare array in one place, which I do right here, in my main function, assuming this is my function A, if this one is declared here, this array, it can only be seen here. This array, this num array, it's pointing over here. So this main function can see this array. Now I'm passing this array. Notice that I'm passing right here to function A. So function A captured this array here. Now when you pass an array to another function, the chapter is telling you it is passed but reference only by default, which means this function is also looking at exactly at the same location. So both functions are focusing in the same direction. You guys are following? If that's the case, if I modify this array, let's say I'm modifying it here, I'm reading from a user, from a file, from different sources, I modify it here. Let's say I populate a value 25 here. This 25 will be modified by this function A, but it is instantaneously available in the previous function. So let's say I jump directly after modifying this value to main function. I say show me the 0th element value. It's going to show me 25 because both functions are focusing on the same location. It's like yourself and myself or somebody else, we are focusing on the same document. There's one document all of us will be working on. You know, in Google Docs and other types of documents, cloud computing, you can focus on just one document, one spreadsheet, one PowerPoint. So you don't have to create your own copies. That's exactly what we are doing here. We are just focusing on one location. How do I tell that function it's an array? Notice that the way I'm passing, that's exactly how I passed my simple data type in the previous chapters. How does the other function know it's an array? Help me out, guys. The square brackets. By looking at the square brackets, this function says, oh, you know what? It's an integer. That's the name of the variable. It's not a simple variable. It's a structured variable. It's an array. So by indicating by using these two square brackets. So when I pass an array, the only thing I'm adding here in this case is the square brackets. Okay? If I don't have square brackets, then this function is going to handle num as a simple variable, not as an array variable. Okay? Yeah.
Can you just call it by saying num and square brackets, or do you need to have the int in front?
So in order to access it, that's what you're saying? Yeah, so you will be using square brackets, because if I simply say here, let's say in this function, cout num, if I do this, it's going to display the address of that location. And I'm not really interested in address at that time. I just want to access the contents of that location, because we mostly deal with the contents. So address, yes, address allows me to find the underlying location address, but my main purpose is to use arrays to access the contents, manipulate the contents. That's the main purpose, to make my programming easier. Also, arrays are very picky about size, as I indicated. So that's why I'm passing the size. So when I cycle through this function, so this function does not accidentally try to access something which is not part of the array size. So it's always a good practice to send a size. If you don't send a size, and if you know I can only cycle through 5, you can put 5 here. Then you can ignore that. But in a larger system, you just want to provide the proper and complete information to the other function. Okay, so arrays are passed by reference. Do not use symbol ampersand sign. There's no need to use ampersand sign anymore when declaring an array as a formal parameter in the other function. Size the array is usually omitted if provided it is ignored by the compiler. Example is you're passing 2 arrays here. I would actually send the size as well. I would definitely send a size, because size will allow me to figure it out how many elements I'm going to cycle through. Sometimes you do not want the other function to modify your array. You want the other function to access the contents, but you tell the function, you know what, you can only display the content or use the contents in your calculations for processing, but don't modify them. So an example could be you give something to your neighbor, such as camera. They are going for vacation, and you say, you know what, here's my camera. Please do not change any settings on my camera. Here's my car. Do not change any settings. You can use it, but don't change any settings. That's what we are saying, that you can prevent a function from changing the actual parameter when passed by reference. You can use const right here, const constant. So in this case, y's elements can be accessed, but they cannot be modified. So that particular function, example function, cannot modify the y contents. It can still modify the x contents. It can still, and there it is, and it can modify x, but not the y. It can access y, but not modify it. Okay? It's a good practice if that function is a print function. If the function is a search function. So it's a good practice in that case. So we talked about base address. So a base address of an array, the first array component. If list is a one-dimensional array, its base address of list 0. I'm going to show you this base address while we are talking about this one, so it gets a little bit more clear. And here's my array, and tell me how many arrays I'm declaring here. How many arrays I'm declaring here? Two arrays, right? One is called ID of integer type, which means in that ID array, I can only store integers. I cannot store something else in ID array. So if this is declared as integer, I can only store integers. The other type is string. I can only store string kind of data in that array. So there are two arrays. If this first name belongs to that ID or vice versa, let's say this individual with this ID has this first name, these are called parallel arrays. The data runs parallel to each other. For example, let's say ID 1 belongs to John, and then there's last name and email and address and other types of data. That will be parallel. It will run parallel. So as a developer, I have to be careful. I have to be careful that all the 0th indices belong to John of each array element, each array. So this is a simple example of parallel arrays, and we'll have more discussion in parallel arrays in a few minutes. And notice that the size, what is the size here? 5. And the C++ is very picky when you declare your array. You need to tell C++ compiler beforehand what is your intention. So you go to a restaurant, you say, I'm expecting 500 people for my wedding ceremony. So they need to know exactly how many meals they have to cook or how many assignments they have to do. In that case, they are very picky about it. Here, my compiler is very picky about it. I have to tell my compiler size 5. So it goes to the memory, goes to the operating system, with the help of operating system, creates that much space for you. So when you're ready to store data, manipulate the data, that space is available to you. However, I'm cheating here. What exactly I'm cheating in ID? I'm not providing a literal value, am I? I'm providing, looks like a variable, right? That should be illegal. That should be illegal. So let me show it to you. Let me prove it to you. So let me get rid of this one. And in fact, it's telling me it's illegal right now. But let's look at the error message. It's illegal. It's telling me, let me see, there's another variable. Yeah. Expression, you cannot read in the back, but expression must have a constant value. It's telling me when you declare your ID, your size is a variable. Variable is something which can vary. Might be 5, might be 7. You cannot do that. Compiler says, you know what, in order to use, you want me to use arrays? Tell me a fixed size. Don't just play games with me. That's what it's telling us. It's very picky about it. Why? Why it's picky about it? Because at the time of the creation of array, it needs to know that size. So it goes and creates that much space. But there's a workaround it. What I can do, I can declare my size as a constant. If it's a constant, then it's a fixed value because this cannot be modified to anything else. So you can actually use, which looks like a variable. It's not a variable. It's a constant. So in that case, it will allow you to create it. Got it? So you can use that way. So once your variables have been declared, I want to see the initial value of the first element. So this is how we can see the initial value. Or let me talk about the base address. Let me look at the base address. So let's say base address of ID. So if I want to see the base address, I can go this way. I'm going to put a system pause here. Okay. All right, so I run it. It's going to show me the base address. Here is the base address. So if I simply use the ID, it tells me the starting error. Now I'm going to prove it to you that this is really a base address. So let's actually look at the base address in another way as well. So if I say cout, and if I say ID 0, what will be displayed here? Yeah, so whatever the initial value is. Let's say the initial value is 25. What will be displayed here? 25. If I put the ampersand sign there, ampersand sign here, then I'm expecting that will be the base address of the first element. Don't you agree? So let's try it. If these two addresses match, and they do in this case, so either I display this way or ampersand sign ID 0, they're the same base address. BE0, BE0, same base addresses. So that proves it to me that these are the base address. What if I want to see the second base address? For example, I want to see the base address, I shouldn't say the base address, address of the second element. So let's put this one here. And in order to see the second address of the second element, this will show me the address of the second element. So first one is 6C0, 6C4. Why 4? Integers are 4 bytes. So it looks like it's actually the neighboring elements. Neighboring spaces are being generated. You guys are following? So this is the base address, just like this one. And I can access this base address just by using ID. I don't have to go use this method. I can use just the name of the variable, name of the array variable. Okay? Let me ask you another trick question. What if I do this? Cout, ampersand sign, ID. What will be displayed in this case? I know if I do this, this displays the base address. And now, if I put the ampersand sign with ID, what will be displayed? So if I run this one, you can see 704, 704, 704. So that's why ampersand sign is not necessary. Because if I simply use the ID, or if I use this method, or if I use this method, it's just giving me access to the same address of that starting array. So it's simpler, just use this ID when you pass it on to another function. And when you pass it on to other function, you just need to use the square brackets to indicate that it's an array. It's not a simple variable. Okay? Just wanted to share that with you while we were discussing this concept here. So that's the concept of the base address. So C++ does not allow functions to return a value of type array. Now here's the thing. If I'm populating my array here, and because I'm pointing to the same direction, same location of in the memory, why do I need to pass it on? It's already available. Did I lose someone? I know some of you are. What I'm saying is that if I populate this array, all the elements are populated here in this loop. And because this function is looking at the same location, why do I need to say return this array? There's no need to return. It has already have been returned successfully. All the contents are previously available. So that's why it's just like there's really no need to return the value of that type. It's already available to you. So, and you can declare array of any type. You can actually declare of constants. We talked about it. I'm going to talk about sequential search because it ties in with our discussion here. Now, because arrays, you can have multiple pieces of data. You have 5 pieces of data, assuming it could be 5 million or 5 billion, doesn't matter. What if I want to search something in the array? How would you search? Sequential search means start with the first one and go sequentially. Go and compare with each one. It's a very inefficient way to search, but at least we have some technique to search our data. And there are other types of searches you will learn in advanced programming data structure classes. But how do I search? How would you search? Let's say I say, can you search this array and see if you have 11 in there? What's the first thing would you do? So you'll use a for loop or while loop, some kind of loop. Sure, I agree. You'll compare with the first one. If it doesn't match, move on to the next one, and the next one, and the next one, and the next one, right? That's what the sequential search is. So in sequential search, this is what a sequential search looks like. You say, you know what? I'm going to run this to the entire size of the array. Let's say the size is 5 or 5,000. I'm going to run through this one, and assuming that array is storing names, could be numbers, could be anything, pick up the first element, compare what I'm searching for. I'm searching for John, or I'm searching for number 11. Compare with the first element. If there's a match, tell me there's a match. If there's no match, continue. Pick up the next one, and the next one, and the next one. Now you have a choice. As a developer, you have a choice. If there's a first match, you can exit from this loop. Or you continue. You continue. You say, yeah, well, I did find one. Let me see if I can find more. So based on how you want to search. Okay, so that's a sequential search. Really, really simple concept. Not very efficient, but it's available. Okay, so in your book it says it's called linear search or sequential search, searching a list for a given item starting from the first array element. Compare each element in the array with the value being searched for. Continue the search until that item is found. So we'll be developing our search, and we'll be embedding our code in our project number 8 as well. Which means the code I'm going to provide it to you. You just need to implement into your own project. So, and you say, well, how do you find search code? It's in your book. Let's say you say, well, I don't like to read book. I have never picked up the book yet. How do you find it? You just Google on it. Doesn't matter where you're sitting. It's exactly the same code. Anything we will be discussing with search and sort, it has been developed for decades. It's the same code. I learned the same code. The code is already available to you. How do you implement it? How do you put it together? Are you searching on based of last names? Are you searching based on IDs? Searching based on zip code? Whatever you're searching for. Then there are different types of sort. Before I discuss this one, I would like to show you a dance. Anybody is interested in dancing? And if we go to YouTube, people take this stuff seriously, really seriously. So let's see if we can find bubble sort dance. And you can find a lot of dances, You'll find mostly East European dances, Gypsy dances, Romanian dances, Hungarian dances. Now our universities are also interested. In fact, I'm thinking about starting a club, dance club. Are you interested? We can actually do on our 1 hour of code day or one of those days, we can celebrate and we can have a dance. I'm going to show you this dance, then we'll talk about it. So this is a bubble dance in Hungarian, but if you're not interested in Hungarian, you're interested in some other dance, trust me, there are a lot of dances available. Notice that on this side, so many dances. And these look like Americans. So, but mostly you'll find people dress up, German dances and all these types of dances. They take it seriously. So guess thousands of people are sitting, and all these are geeks. So all the geeks are sitting in one place. So, but let's look at the bubble sort, and then we'll talk about it. So turn on the volume here. Of course, I'm not going to run the whole thing. I'll just run for a couple of minutes. Right here. Okay, so this is your data. I'm going to stay here because I want to capture it. So that's your unsorted data. 3, 0, 1. This is all unsorted data. And now notice that once the data is there, you'll see the elements and indices. So first comparison is happening between the first two elements. So they compared and swapped. 0 is smaller than 3. 3 is larger than 1. So they're going to swap that data as well. That's the second swap. They compare this one. There's no swap in this case. They did the comparison, no swap. This swap will take place. The goal is to, in this ascending order swap or ascending order sort, because smallest and larger, the goal is to find the largest value and bring it to the end. So you'll have 2 for loops, one which can go through this one, and the second one go to the next cycle. So we'll see the second, and I'll stop. So 8 is greater than 4, but notice that 4 is still smaller than 5, so we have to go through this few times. The last one, we don't need to swap anything because this one is already smaller than 9. Now this is the first for loop. Then it goes to the outer for loop. Comparison is happening. No swapping is needed. No swapping is needed. No swapping is needed. However, we need to swap this one. And that swap will take. And you understand how it works. And again, if you're interested in other types of sorts, which we'll be discussing in our data structure classes, there are other types of sorts are available. And there are companies. Can you name a company? Their whole business is about search and sort. Which company is all about search and sort? Google. That's their business. So that's exactly what they do. They search and sort. In fact, search by itself is useless without sort. Search and sort are married together. So if you say, I can search anything in Home Depot without sort, that will take a very long time. I can go to Walmart and search without sort. That will be very, very difficult. Imagine if every single item in Home Depot is mixed with other items. They are not in shelves, they are not in aisles, they are not in by department. How difficult it would be for you to find one type of screw for plumbing versus carpentry. It will be very, very difficult. And everything is properly sorted. So these companies, they figured out the best sort criteria and best search criteria. What type of search do they use? Do they use sequential search in Google? So, can I find out what search and sort mechanism they use? No, they have to probably kill me. That's their trade secret. That's their $100 billion secret. So they actually have hired hundreds of PhD mathematicians and people with statistics background to create these search and sort algorithms. That's their business. That's exactly what they do. Same thing with Twitter, same thing with Facebook, same thing with many other companies, Amazon. So they are experts in search and sort. So search and sort is a serious business. That's why people take it seriously. They have probably technology days, computer science days. These are university people. So that's why I'm inviting you, come and join this dance movement. We can start this dance movement. So, but anyways, you can see there are different types of methods. There's German dance, there's Gypsy dance, the Hungarian dance, and Romanian dance. We need to have Long Beach City College dance. So let's come back here. So the type of sort I would like to talk to you about is called bubble sort. And that's the sort I just demonstrated to you. Let me show you the bubble sort. So in bubble sort, this is where the sort is taking place. One of the things which you noticed in the dance is the swapping. So if the one item is smaller than the other item, basically we are checking the ascending order. You can make it descending order because when you go to a spreadsheet, for example, Excel, they ask you what type of sort you want, ascending order or descending order. And in ascending order, you look at the you look at the first value. This is the first element value. You say if this value is greater than the next neighbor, remember they were comparing. One element was being compared with the next element. If this one is greater than the neighbor, then swap it. And this is what the swapping is. I want to hold on to this value which is greater in a temporary variable. If I don't put in a temporary variable, what will happen? If I don't have this statement here to put it in temporary variable, what will happen? I might accidentally overwrite and lose the contents of that element. For example, if I don't have a temporary variable, I say take the second element, put it in the first element. If I do that, what happens to the first element value? It has been overwritten. I'll lose it. So that's why I want to hold on to this this value into temporary variable. Then I go to the second element and say, okay, I have that value in my temporary variable I can assign to you. So that's the swapping is taking place. Swapping is a really simple concept. So that's where the swapping is. That's where the comparison is happening. Now, what if you want to do the descending order? What would you change in the code? So there's something else simpler than that. Yeah, just this one. If you change this symbol to less than symbol, that would be a descending order. So, and then why do you need two loops? Because let's look at the inner loop first, the inner for loop. You start with the 0th index. 0th index is the first element, and you're comparing with the size -1. N is the size. Assume that n is the size. So let's say there are 10 elements. 10 minus 1 is 9. What is the 9th element? Starts with 0. 9th element is the last element. You guys are following? 9th element is the last element, technically. Because I cannot say 10, 10 because there's nothing in that last, in that element. So that's to go through the entire array in that order. Start with the 0th, compare with the next one. If that's not the case, continue, start with 1, compare with the second one. 2, compare with the third one. Compare fourth with the fifth one. Fifth with the sixth one. Sixth with the seventh one. Seventh with the eighth one. Eighth with the ninth one, and then stop. If there's a swap, yeah, do the swap as well. Then go back and notice that we start with I equals to 1, and also it checks the size. Then my outer loop is going to go to the next element. Next element is the second element, because remember, now the smallest value has been identified and it has been placed in the correct place. Now go and compare the next cycle. So you go through this a few times. So this is your bubble sort. Here is the code. It's available on our website. Here is the code. Your job is to take this code, copy it, put it in your own code, and see if you can sort as well. It's already available. It's already there. It's already available. But make sure that if you're sorting by last name, your variable has the correct, it's the correct variable. One thing I'm going to indicate in a few minutes that this might have some technical issue, which I'll show you in a second. Let me go and show it to you. So let's say this is the data I want to read. Right before a class, I added this data. There are 5 people from our class. I have Salim all the way to Adam. Notice that there are some fictitious IDs. So Salim has ID 1, 2, 3. And Salim, can you remember your ID? Because I'm going to show you something. So your ID is 1, 2, 3. Jacob, you are 854. And Adam, you are 159. Okay, just remember these IDs for a minute. And Zainab, you can remember yours. Daniel, you're 456. So these are the IDs. So I'm going to read these IDs. The way the program is structured, I'm reading these IDs from the user. I'm not going to read from a user. It's just a waste of time. So I'm going to just get rid of the comment out of this part here, get rid of C, comment out of this part here, get rid of the C. Assuming this is my ID and this is my first name. It says, well, we don't recognize these. This in object. Let's create this in object. I'm going to create it right here. in.open. Oh, it's not recognizing because I have to include the library. And this file is called data.txt. So let me include a library here, ifstream library, or fstream. Okay, so then we are picking up the data right here. Okay, so my goal is to pick up this data. But let me show you how it is laid out. Let me run it, then I'll talk about it. So when I run this code, I need to close this one first. And in fact, I don't need to show you the addresses anymore, so I'm going to comment this part here. Comment that part. Okay, let's run it again. So when I run my code, I have these, it's a menu with 5 options: display the data, fill the data, search the data, sort the data, and quit. And again, you can make it more beautiful and you can make more choices. You can add 10 other choices. But let's say these are the choices. Right now, I have not read the data yet. And if I say display the data, it doesn't have, oh, I actually must have put one value somewhere. Let me just comment out that part here. Yeah, right there. So let's put this one here. Let's rerun. So if I say display, so as you can see, because when I run the display, because no data was read, so my arrays are empty, as you can see. Okay. So I have another function which I'm going to call, which is called fill an array. This function, when I run this one, it says in the change value function, that's the name of the function, values have been updated. Okay, if they're updated, let's verify. So I hit my enter key and I go and look at the values. So successfully we picked up Salim's data, Adam's data, everybody's data is there. Notice that Adam is in the last array element. Salim is the first array element. So guys, remember your IDs for a minute. Now I want to search something. I go back and say, you know what, let me search. Again, I have the ability to search on anything. My program should be flexible. It should give you 4, 5, 6 choices. So when you call your credit card company, they ask you, what's your social? You say, well, I'm not going to provide you my social. What's the next thing they might ask you? Probably your address, right? You say, okay, I can give you my address. What if you have people with the same last name on that address, like your siblings or parents or somebody else? Then they might ask you about date of birth. So there must be multiple criteria to search something. Here I'm searching by the name. So I say I'm looking for Adam. If I put Adam, it tells me record number 5 has Adam's information. And I can display Adam's information. If I have access to Adam's record, I should be able to display his information. So it means my search is working. If I go back here, I'm going to sort the data. You guys remember your IDs? So here's a technical problem. So it identified the unsorted IDs were 1, 2, 3. Last one is 159. 159 belongs to Adam. 1, 2, 3 is Salim's. And it sorted these IDs, as you can see. 1, 2, 3 is the smallest one. 159 is the next one. 4, 5, 6. 7, 8, 9, and 8, 5, 4. So it looks like everything is sorted correctly. So what's the problem? The problem is, let's go back to the main menu. And this time I said display my data. All right, when I display my data, Salim is in good shape. However, Daniel, what was your ID? Now in this case it's showing me 159. Adam, what was your ID?
159.
159 is showing you 854. So I have a very bad programming code. So it messed up my data. Imagine, by the way, these things do happen in the industry. Used to happen frequently. I remember so many people, they went to DMV to renew their driver's license. They got their name, but somebody else's picture, or vice versa. My friend, he renewed his driver's license. He got driver's license. He had his name and address, but the lady's picture. And another person I remember got his picture, but somebody else's data. So this is the programming issue, the code issue. That what I did, I swapped or sorted the data. I swapped and sorted the data, but who can highlight what mistake I made here? So here I'm swapping the IDs. What mistake did I make here? Only the IDs. There is some other parallel arrays associated with that ID. Remember, ID 1, 2, 3 for Salim has also parallel array for first name. I forgot to swap the first names as well. So I must be swapping first names as well. So in your code, when I ask you to swap something or sort something, not only sort or swap these IDs, also underneath you need to swap their first names too. Otherwise, the data will not be properly aligned. That was the problem we had. Okay? So just wanted to highlight that one. How did I run this program? Well, I have a simple this menu in my main function. This menu runs, and it's available to you. You don't have to write down anything. It's already available to you. So you have 5 choices, and user picks up a choice between these 5 choices. And then based on that choice, you call that function. If somebody says choice 1, you call display function. Somebody says choice 2, you call change value function. Somebody says choice 3, search function. Choice 4, sort function. choice 5, exit. So these are the 5 choices. So once the choice is picked, so because everything was declared in my main function, here's my main function, my arrays are declared here. Of course, the arrays are empty. There's no data assigned to these arrays. But when I pass on these arrays, let's look at how these arrays are passed on. I pass on my ID, first name, and size. Size is just telling me the value 5. So my ID and first name are being passed. So I jump directly to my change value function right here, change value. I am picking up the ID and first name as an argument. So I'm picking up these as arrays as arguments. Once they're picked up, they have full access here. Then I start populating here. As you can see, I opened up my file, and I started populating the data right there. So my IDs will be populated here, and my first name will be populated here. Now you might argue that here you're calling them num. In the previous function, you called them ID. In the main menu function, or in main function, I call that ID as array. Here I'm calling as num. How come I'm pointing in the same direction? It's irrelevant because you can give any label you want. Like if your name is Adam here, at home your name might be, I don't know, darling, sweetheart, or whatever. You see what I'm saying? It's the same person, but you might have different labels. So if I call it ID or num, it doesn't matter. It's the same thing. It's pointing towards the same memory location. Once you have access to those arrays, you can populate them here. Once they're populated, they're instantaneously available. Notice that this is a void function. Void function does not return anything. Am I returning anything from this function? Absolutely not. There's no return keyword. But because they were arrays, when you populated them here in this change value function, the data is available at the previous level. So if the data is available, when I come back to the main function, I come back here, I can call display function because data was already available. Instantaneously, display function can see the data. Search function can see the data. Sort function can see the data because they had the full access. Okay, this makes your concept of array really powerful. Imagine if you had 5,000 of these, and you don't have to pass ID1, ID2, ID3, ID4, ID5, ID6 all the way to 5,000. That will be crazy. That will be really, really difficult to write code. Here, it gives you a structured way to access large amount of data. We didn't have that ability before. You guys okay? You will find array is in every single modern programming language. You will hear the word arrays over and over again. In fact, what if I tell you from the very first or second lecture, we have been implicitly using arrays without our knowledge. Is that true, Clinton?
I'm assuming the arrays with just one.
Strings. So strings are by default arrays of characters. Strings are by default are characters. Let me show you something. I think I probably must have done this in the past. But let me show you something really interesting here. I have a string variable, string L name equals Clinton. So Clinton, this one is, let's say this is your last name, okay? Assuming. And let's say this one is not an array, as you can see. Doesn't look like an array, right? So what I'm going to do, I'm going to, what will be displayed here, Clinton? Your name. What if I do this? Do this. Now this looks really crazy because I can only use square brackets with an array. This doesn't look like an array. But if I do this, I'm saying show me the first element of that array. And funny thing is, it's not even giving me an error message. I was expecting an error message. And if I run this, it doesn't give me any error message at all. And it picks up C. It picks up C. So that proves strings by default are collection of array or collection of characters. So the string by default is an array. You guys are with me? So we actually have been using string as arrays in the past.
Aren't strings typically implemented as something like a vector so that they can be dynamically extended?
That's exactly right. So we have another concept called dynamic arrays. Because the problem with arrays in this chapter 8 is that the size is fixed. What if you want to increase the size? You say, you know what, I'm not going to tell you the size, or I'll tell you the size, but what if I want to change to 5 to 20, or 80 or 100 or whatever, dynamically during the runtime. So there's a concept called vector. Vectors are dynamic arrays. They can change the size dynamically during runtime, which we'll be discussing in advanced programming. Okay, so that proves our point that we have been using these string concepts in the past. So let me see if I want to share a couple of other things. We talked about the declarations. We talked about arrays as strings. Strings are by default. I just verified that one. You can also compare them. We have used strings for some time. We are pretty comfortable with strings. Just how to take the input. I already showed you that, how to produce an output, how to read a file, parallel arrays. We discussed the concept as well. Two-dimensional array. Let's talk about two-dimensional array. I might have an example here. Otherwise, I have two samples. This is the one I'm using for this demonstration. There's another one. There are two other ones. So there is another sample here. I think it talks about two-dimensional array, not this one. Let's go back here. Yeah, this one here. So this one talks about two-dimensional array, and I'm not going to read from a file. I'll just make it smaller. So let me see if I can comment this one out. I need these libraries. Okay, so I'm not going to read from here. Let me just get rid of this one. Let's make it smaller. 2 by 2. That's fine. But let's read this from the user. Okay. Okay. So we actually talked about single-dimensional array. So this is what a single-dimensional array looks like. What if I want to declare a two-dimensional array? Let's see what the two-dimensional array looks like. And because I don't have too much space, what I'll do, I'll just declare size of 2 of 2. So if I declare int, and I call it records. You can call it anything you like. Records, and size 2 by 2. So here you're saying, I would like to have 2 elements. And this is my single dimensional array, 2 elements. And here's my another array, 2 elements. Each one of these, so this array is going to point here, and this array is going to point here. So visually, this is what happens when you declare an array. So this one is called records. Records is pointing here to this location, 1000 for example. So when I say show me the element, or let me access the element here, this location is pointing towards another memory location with 2 elements. So let's say this one is 0, this one is 1, this one is 0, this one is 1, this one is 0, this one is 1. Now if I put it together, it would look like this, like a matrix. If I stack them together, if I stack them right here, this is what it's going to look like a matrix. And this starting address is called records. Records. So this one, if you look at the columns, this is the 0th column. This is the first column. If I look at the rows, this is 0th row, and the first row. So this is an example of two-dimensional array. Behind the scene, it's doing like this. But for sake of understanding, we pretty much understand this concept here. And this is an example of Excel. So Excel has cells, and Excel has rows and columns. The intersection of a row and column, that's where the data resides. So if I want to access this location, let's say this location has some data. It has some data here, 25, this has 18, this has 6, this has 3. How do I display 25? What do I need to say here? Cout? Help me, guys. What's the name of my array? Records, absolutely. Records. And it's a two-dimensional array. How do I display 25? So it's a 0th row and 0th column. So I'll say 0, 0. If I want to display the last data, which is 3, it's the first row and first column. First row, which is, and don't misunderstand the first row. First row means the second element, because it starts with 0. So basically, this is the row number, this is the column number. So 1, 1. That will allow me to access. And that's exactly what we are doing here. So I declare rows, and row is a constant, which is size 3, and column is a constant size 2. So 3 times 2, so 6 size is 6. So for the outside for loop, I'm dealing with rows. For the inside for loop, I'm dealing with the columns. So the outside, which basically, first I'm going to go to the 0th row. Then within each row, I have multiple columns. So I'm going to go to the 0th column and the first column. That's what we are indicating here. Once that's done, then I go to the first row, row number 2. Then again, start with 0th column and the first column. That's how I can populate the data. So when I run this one, I was previously trying to read from a file, but let's read from the user. I probably have to close something here. Okay. And it's asking for the data. I'm going to just throw some fictitious data. Okay, so that's my data. So I actually ran through, populate my data, and the data actually resides in this kind of format. Over there I have 3 by 2. Here I have 2 by 2. So my two-dimensional array is 2 by 2. Okay, and the good example is always the example of Excel spreadsheet. So in the previous for loop, I'm actually using to populate it. Here I'm actually displaying the data. Once the data has been populated, I can simply display it. How do I pass my records to another function? Let's see if we can create another function. Here's a function, and guys, try to help me. Here's my function. I'm going to call it fun, and I'd like to pass integer records, and I would like to access some kind of data here. And records, help me pass this records array. And let's put this one on the top of main function. Help me pass, because records is an array. How do I tell the other function? How do I tell the other function that it's an array? What did I do for this single dimensional array? What special operator did I use? Square brackets, right? So here, if I use square brackets, that's good for one single dimensional array. If I use square brackets, but it's not a single dimensional array. It's two-dimensional array, right? So shall I use twice? Shall I use twice? If I use twice, let me put 0 here and 0 here. If I use twice, let me make a copy of this one, put it above here. And Is it happy or it's not happy? Looks like there is some issue right there. And let me read the error. An array may not have elements of this type. Although records is a two-dimensional array, so it's saying that there's some kind of mismatch. Let me run this one and let's read the error message. And the error message is, array may not have elements of this type, and that's basically missing subscript. Here it's telling me missing subscript. It's telling me that something is not right in my array declaration. So what would you do? You're sitting by yourself and in your company, and you forgot the method to use two-dimensional array. Could be three-dimensional array. What would you do? What's the first thing would you do? Let's say you don't have your book with you. You don't have any of the source. What would you do? Let's Google on it. So let's go here, and let's say we say C++ two-dimensional array function pass, function parameter, and passing a two-dimensional array, and here it is. Okay, there it is. Let me make it larger. That's what I want to show you. Yeah, there are multiple ways you can handle it. So here's my function. In my case, my function is called fun. It's a void function. It's an integer. That's the name of your array. Here's your first square bracket. Here's your second square bracket. In the second square bracket, it wants you to tell that array what is the total number of dimension for that particular second part. It basically wants you to tell it how many elements are there. So although this array was declared as 10, 10, but when you pass it on as an argument, you need to tell in the second square bracket. If I come back here, if I put 2 here, and if I put 2 here, let's see if it's satisfied. Looks like it's happy with that one. And we probably, we probably will be, and we call this function is called fun. So immediately after this one, I'm going to call this function fun records. I pass it on records, and that's how you pass on array to another function. Let's run it. So again, we just add some fictitious data. And here's my fictitious data: 56, 78, 100, minus 88, 4, 69. And then I actually accidentally did not put ENDL, so that's why you don't see there's a space, but you will understand it. So my data was populated here. 6 elements, 6 pieces of data. 6 pieces of data was populated 1, 2, 3, 4, 5, 6. And then I go back to the fun function. Go to the fun function, jump to the fun function. In the fun function, I'm trying to see what is the first element. And it shows me the first element. Okay, so when you're passing a two-dimensional array, just the only thing different you will be doing is you provide the size of your column. So you pass the rows and columns, you provide the size of your columns. All right, that's the concept of two-dimensional array. Am I going to use two-dimensional array for project number 8? Answer is no. You don't need to. Unless you want to, but there's no need. All you need to do is use a single-dimensional array. Single-dimensional array will work for our program. And it tells you how to access it in your chapter, tells you visually what it looks like. Just like matrix, I have it here. So, and it shows you they can be initialized just like your other data processing two-dimensional array, row and columns, which we have discussed, how to initialize it, how to print it, how to get the data, how to do any calculations, sum by column. Then it talks about how do you find largest passive two-dimensional array. I already demonstrated that to you. It's also available on our Moodle site. Arrays are strings. Strings are basically collection of array characters. And in fact, let me last comment I would like to make is if you declare something like this, if I can get your attention, if you declare an array of strings, this is very interesting because let's say you declare string names, let's say, just to keep it simple, 3. How do you read this one? So you're sitting in an interview, somebody asks you, can you read this for me? How do you read it? It's a string array, right? String array. How many values you can store? How many names you can store? 3. Also, arrays, strings are by default what? Arrays. So it's an array of array. So it looks like it's already a two-dimensional array. Because strings by default are character arrays. And for each character, I'm saying I'm going to store these names. So behind the scene, if you want to visualize it, so it creates an array like this, size 3, 1, 2, 3. 0th element, first element, 2 element. And this one is called names and is pointing in this direction. So if I want to store, let's say I come here, names, 0, John. If I want to store John here, where exactly John is stored here? Is it stored here? It's not, because it's a collection of characters. So it's not physically, it's not stored there. That's what Daniel was referring as well, that it can grow in size. So I can change John to Johnson or Jonathan. So it can grow in size. So what happens, it's not storing John there, it's storing John somewhere else. It says, you know what, I'm going to create this location, another array for you, and I'm going to store J here as a single character, O as a single character, H, N, and end of your array. End of your array. So to indicate this is where the string ends. So let's assume this is the address 2000. So at that location, 2000 is being stored. Similarly, this will be somewhere else. This will be somewhere else. So these 3 array elements of string type, they're pointing another part of the memory. Now in this chapter and probably somewhere else, in another class, somebody says arrays are immutable. Help me understand what that means. You know, you probably understand mutable, right? Mutable. Mutate. What's the name of the cartoons or that show? Ninja. Yeah. So immutable is something which cannot be destroyed. Arrays cannot be deleted, cannot be easily modified. So when you change your contents here, you say, you know what, I changed my mind. It used to be John, I want to call it Mary now. So same location, so I'm going to call Mary. Do you think it's storing M-A-R-Y there? The answer is not. It says, you know what? Okay, you change your mind. I'm going to create another location. That's where I'm going to store Mary, M-A-R-Y. And I'm going to just simply point my arrow from that location to this location. I'm going to leave this one the way it is. Because strings cannot be deleted, cannot be muted. They are not mutable. Cannot easily be overwritten. So in the memory, it's just pointing in a different direction. That's what it does. Okay? So just in case if you read something and if you get confused, visually this is how you want to see it. Okay, I'm almost done, guys. So, multidimensional array and talks about it, and that's the end of the chapter. Let's talk about the project. And the project is, I think, based on our book. So let me grab our book. And let's see the page number. So it's page number 603. And this is the exercise number 7. So in this exercise, write a program that allows, this is page 603, number 7, write a program that allows the user to enter the last name of 5 candidates. So there are 5 candidates with their first names, or last names, whatever you want to call it. Last name is fine. And they have, these are the number of votes they received. Your job is to find the winner. Who has the highest number of votes? So you need 3 arrays, at least 3 arrays. 1 to store last names, 1 to store number of votes received, 1 to store the percentage of the votes received. How do you get the percentage? If I want to calculate the percentage for Johnson, 5,000 divided by what? Total votes received by all the candidates. 5,000 divided by 19,300 will give me 25%. So you need at least 3 arrays. One for string array, another for double. Use this one as a double, and use this one as a double. So 3 arrays. And when you declare your arrays, the data should be populated in one function, and this will be picked up from a file. You don't have to type this data. Just like I have the data right here. I had the data just like here. So I have Salem and ID. You'll have Salem and number of votes received, which is Johnson 5,000. And you will have this simple, very simple data file. Two pieces of data. One is the name of the candidate. One is the number of votes. So once you pick up the file, and that data should be read in a separate function. You say, well, I don't know how to read the data in an array in a separate function. It's already available to you. Remember the change value function I was demonstrating? It's there. So use the function. Why don't you use the menu I have? Just use the menu as well. So you have a menu option, read the data. You have the menu option, display the data. You have the menu option, search the data. So if I want to search how many votes received by Miller, I should simply type Miller. It should populate the data. You have a function called bubble sort. Use that function. So when you sort, so Johnson is 5,000. And let's say you sort by votes received, lowest to highest. Make sure you are also sorting their names as well. Do not mess up their record. The error I was showing you, the logical error I was showing you in my code. All right, so you should be able to find the winner. And all the data is in arrays. So you must use functions, you must use arrays, and you must have the search and sort option. Those are the 3 requirements. It doesn't say those things here. It doesn't say all those things. The program should then output each candidate's name, the number of votes received, and the percentage of the total. A sample output is shown, and the winner is Duffy. It doesn't specify search and sort and functions, but I need to see that. Okay? This is an easier program, much easier program. So we should be able to, and I invite you to use the function the program I have, customize that program in order to accommodate these users here, these candidates here. This will be due on the 12th, which is the next Sunday. So if you came late, this is where we are currently. We are done with chapter 8. Chapter 9 is a smaller chapter, but it's an important chapter. That will be the first time we'll be discussing data structures. So I invite you to study data structure in chapter 9. So when you come back, we'll have a pretty good understanding. And I think our lecture will be about an hour and a half, around that for next Saturday. When we come back on the 18th, we'll be done with our required curriculum. On 18th of November, we'll be done with the requirement of the department, which means the first 10 chapters. So we'll meet the criteria for our class. But there will be no class the following Saturday. So we'll be taking our online exam that week, not on Thanksgiving Day, not on that day that you cannot eat your turkey before you take the exam. So it's going to be available for 7 days. So you can take the exam anytime that week. Take on Monday, take on Sunday, whenever you are available. If you're planning to travel on that weekend, I know I'll be in a conference for 3 days. I'll be presenting somewhere. So I invite you to take the test beforehand. Take the test on Monday, Tuesday, Wednesday of that week. When we come back the following week after Thanksgiving, we'll be working on Windows programming. So I know some of you say, you know what, I don't really care what you have been teaching us. I just want my C grade. I just want to pass this class for this requirement or that requirement, or for this thing or that thing. So that's not the mindset I would like to carry. I would like to carry that this is a learning opportunity. Imagine if somebody's teaching you so you can make maybe $1 million for next 20 years or so. Wouldn't you go to that free opportunity? You know, you hear on the radio, come join us a real estate seminar. We'll give you a free USB or free this thing or that thing. Don't you hear that in the radio or the TV all the time, right? What if I offer you, come and just for 1 week, sit and just learn how you can actually develop like this in an hour and a half. What I teach you, for some reason it's not picking up this calculator. What if I show you some students see this application? What is this application, guys? What if I tell you that 1.5 hour lecture, you can actually develop your own notepad? A little bit more time is needed, but one student actually developed the entire notepad with that one lecture. And many students, they develop their own calculators. They develop their own games, tic-tac-toe and hangman and all these things. Just one lecture. Because you already have the background. You already know how the loops work, how the if conditions work, how to read a file, how to do the comparisons, how to use arrays. All those things are already available to you. You just put it together. So it's just like somebody has showed you different techniques, and now it's time to implement. So Windows programming is the first real test for you that now you can create applications that look like fascinating applications. I think I showed you this in the first week of the class. I'm not sure where I have the code. Maybe right here. So you can develop things like this. With one lecture, you can develop this game here, the number guessing game. This is developed by CS11 student by one lecture. And all these things are objects. So in chapter 10, we'll talk about objects, the objects we will create, and objects which are already available to us from their library. Anybody has taken Java? Java. So when you take Java, it has all these classes available to you, hundreds of classes. Your job is to implement those classes. Somebody has already done the hard work. Your job is to learn how to implement them. So you say, well, I'm not still sure. Well, your job is to how to use it. This is a tool. Somebody has developed that tool. How do you use that tool to make it meaningful for you, make it more productive for you, so you can be more productive throughout the day? That's what the Windows programming is all about. Somebody has developed these wonderful tools, hundreds of them. I'll teach you how to use some of them. Of course, I'm not going to spend the entire semester, but imagine if you spend the entire semester, what kind of great tools you can develop. So I invite you not to skip that class, even if I'm giving you all sorts of ideas, still half of the class will not be here. I invite you to come and join us. Join us. People, as soon as people are done with the exam, they never show up. So I invite you to please join us for something free. I know some instructors, when they are done with the material, they bring cookies and they bring, I know one instructor, a poor guy, he actually used to bring coffee the last day of the class just to entice students to come and visit us. People pay a lot of money to learn this kind of stuff. And here it's absolutely free. This is not even in our book. This is not part of our curriculum. The other teachers do not share this information, but I'm inviting you that put it in your schedule, put it in your calendar. And the reason I don't assign you anything in the last week because you're busy in other classes. I have a student, he's taking in my CS12, he was in my CS11 last semester. He's taking 29 units. 29 units. Yeah. So some of us, we take 12 and we say, well, I'm dying. He's taking 29 units. I don't know. He's taking from multiple colleges. Yeah. 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 I don't recommend it. That he wants to finish the entire bachelor's in 1 year, I think. So I don't recommend it. All right. So that's